Everyone. In this tutorial, I'd like to show you how we can use rviz in order to see the data that come directly from the CAT vehicle's sensors. So in this video, we're going to be looking through rviz at the actual sensors that are on board the car. Let's start by using the simulator that we have up from the previous tutorial. So if you don't have that actually running, you can just run the Gazebo skid pan. So I have that simulation running here, and we can still see it. In a new folder here, so, CAT Vehicle Workspace, source devel setup.bash, and I'm going to run rviz. And when you do this, your rviz file is probably going to be empty. So what I want to do is that I want to let's see, how can I remove everything from my config? I guess I can just come here and delete everything. Hooray! So this is probably something like what you see when it starts up, except that it might be, I don't know what this will show. I actually don't know exactly what this is going to show you when it starts up, but probably your background color isn't gray, it might be black. And there might be a grid there. So let's go ahead and add the grid. So you probably see something like this. My grid is really gray, so I don't know how it comes up for you. I'm holding down Shift to move this around some. Typically I think the background is black, but I like to set my background to gray. We can do this. This is probably more, oops. Here we are. This is probably more like what yours looks like. But what I like to do is I like to set my background color to be something else, because then something that looks black, so for example, I think the car has actually got a bunch of black trim on it. By changing my background color to be a different color, it allows me to see the car better when the car pops up. So we have the grid here. Let's add a few more things. So the first thing that I'm going to add is that I'm going to go here, and then by topic I'm going to select the LiDAR points point cloud. And we see a bunch of stuff here, and it's complaining argument passed, it can transform, argument target frame, blah blah blah, cannot be empty. It's complaining because it doesn't know anything. Let me find here the CAT Vehicle Velodyne link, and now it's actually not going to complain about that anymore. So I can show you that we're not getting those issues. And you can see a lot of little bitty baby points that are popping out here. Or maybe you can't, because it's actually really hard even for me to see them. So what I'm going to do is I'm going to come down to the point cloud, and I'm going to change the size from 0.1 to say 0.05. And now they're all showing up maybe a little bit better. Let's change this to maybe 0.5 just for overkill. Yeah, so now we can see a whole bunch of stuff here that's all flat on the ground until it gets high at the end. So this is no surprise. We're in the world and it's flat, and then at the end of the world we can see that we get returns that say I don't see anything, and so I'm going to tell you that at my horizon I don't have any more data. You can see that by returning a value out here, we could interpret that sensor data to say that well, I didn't see anything just because it's at the limit of what this sensor can have. So we can see this point cloud. Let's go back and look at our tutorial. So we don't see much. We added some more information here. By the way, if you want to skip all this, you can just download the catvehicle.rviz file from the files of the CPSVO, and then you'll be able to see kind of everything as we'll see it by the end of this tutorial. So we added in the Velodyne points. I think it's actually just called the LiDAR points topic. And the Velodyne link is actually the link name. So the next thing that I'm going to add is the robot model. So I'm going to add by display type robot model. Add by display type. Scroll down until I find robot model here and say OK. And now I have a bunch of warnings and errors that is basically complaining that it can't find anything. Parameter robot description was not found by, does not exist and was not found by search param. Well, that's because it's not called robot description, it's called CAT Vehicle / robot description. Well, Now that's kind of an improvement. We don't have the same kinds of error message, but I have this really bizarre looking car that has all 4 tires stacked underneath it, and I can't see anything about it except that it kind of looks like a car. So I'm going to correct this error by adding a prefix to the transformation, CAT Vehicle. And now we can see everything and it looks a lot better. So we can see this big red block on the top that represents the Velodyne sensor. We can see these 2 red squares on the side, those represent cameras. And we can see the 4 wheels of the car. Later when we start turning the car around, we'll see it there. We also see that the grid is centered up here at the top of the Velodyne. So the grid, which should be kind of what we drive on, like that's the floor, it kind of doesn't make sense. And the reason for that is that we select the fixed frame to be the Velodyne link. I'm going to change this from Velodyne link to CAT Vehicle / ODOM. So now we can see that the car is sitting directly on the ground. So it's right on top of the wire frame. And we can also see now that the data from the Velodyne is projected onto the ground. So this gives us an idea that what we're seeing is reflective of actually what's out there in the simulated world. So one other thing that I'd recommend for you to do is to change your point cloud from, let's see, style instead of flat squares. We'll leave them as squares. And I want the position transform, color transform instead of intensity. I'm going to change this to axis color. And so now we can see that for every point that we get back, we get a color that tells us kind of how high it was, which is the number of the axis from the Velodyne. And so these blue ones here tell us that we're reflecting off something that's kind of medium high. Everything that's orange is low and everything that's purple is high. And so that gives us a way to see kind of what's happening by looking at the color. You can infer how far away something is or how high it is. We can add a few more interesting things to our information here. So let's add another one. I'm going to call this by topic the laser scan. So this is the laser scan from the front laser points. We're actually not going to see much of that now. Let's change the size of this to also be kind of much bigger, 0.2. We're not going to see much of this because they're not giving us any information back, namely that there's nothing in this world for us to see. So in order to take advantage of this, I'm going to come up here. Let me see if there's anything else that I need to add. We changed the cat prefix. We added the robot description. We can see the car above the grid. So let's go now to a world where we can detect actual things with our sensors. And to do this, I'm going to save this config. Oops, I'm not sure what I saved it as. That was probably not good. It looks like I saved it as my default.rviz. So I'm going to save the config that I have right now as what I'm going to call CAT Vehicle _ tutorial.rviz. That's what you'll probably want to do. And so with that rviz file, now if you load up CAT Vehicle, or if you load up rviz again, it's going to by default load that profile, and you'll be able to see exactly what you see right now if the car's there. So let's move on now to the next tutorial where we're going to see something more interesting in the data that come back from the car.